Bushfires are an intrinsic part of Australia's environment. Natural ecosystems have evolved with fire, and the landscape, along with its biological diversity, has been shaped by both historic and most recent fires. Many of Australia's native plants are fire-prone and very combustible, while numerous species depend on fire to regenerate. Indigenous Australians have long used fire as a land management tool, and it continues to be used to clear land for agricultural purposes and to protect properties from intense, uncontrolled fires. Historically, bushfires have caused loss of life and significant damage to property. While naturally occurring bushfires can't be averted, their consequences can be minimised by implementing mitigation strategies and reducing the potential impact to areas which are most vulnerable. So what factors create a favourable environment for bushfires to occur? The fuel in particular. So fuel's effect on fire. The various weather elements that affect fire behaviour are interrelated and affect each other. This is also true for the fuel elements and elements of topography. Not only does fuel affect fire behaviour, but we must have fuel to complete the fire triangle and thus have combustion. Unlike weather, fuel does not change rapidly, but most elements remain rather constant. The elements of wildfire fuels are loading or the amount of fuel, the availability of fuels and the size of that fuel load, the arrangement, and in particular that we're going to look at today is the moisture content. Fuel loading is the total amount of fuel on an area that could burn under the most extreme conditions. The amount of fuel has a decided effect on fire behaviour, so large volumes of fuel can result in fire blow-up, fire that is difficult to control. The more fuel burning, the more heat that is produced. And the amount of fuel affects the amount of smoke. So if we have a measurement of tonnes of fuel equals tonnes of smoke. The available fuel is the amount of fuel that will burn at a given time under the situation that exists at that time. Fuel loading is constantly changing and can change mostly on a yearly basis. Many factors affect the percentage of fuel loading. So that is the major one being the amount of moisture, which we are investigating today. Dry fuel will burn quickly, but damp or wet fuel may not burn at all. So as a consequence, the time since rainfall and the amount of rain received is very important in considering and in assessing the bushfire danger. Often, a measure of the drought factor or the moisture deficit will be used as an indicator of extreme bushfire weather conditions. Weather elements will have an impact on the amount of moisture. On most days, half the understory fuel loading will be available to be consumed. So during long periods of drought, most of the fuel can be consumed, resulting in a potentially more damaging fire with high intensity and rapid spread. So such fire will burn deeper and are more difficult to control. The size of the fuel load is really important as well. You may be well aware that small fuels ignite more readily than the larger fuels. It's easy to start a campfire with kindling, small twigs, dry leaves, than it is a log or a branch. The heat that enters a piece of fuel must go through the surface. The time required to heat the fuel depends upon the amount of surface to area volume. So small fuels will burn rapidly. The rapid burning is greatly due to the greater ratio of surface to volume and less moisture. Fast burning generally consists of fuel such as dry grass, dead leaves, pine needles, twigs, and brush. So the larger fuels, called heavy or slow burning, generally consist of limbs, large stems, logs, and stumps. Small fuels and flat fuels are called flashy fuels because of their property of igniting and burning very quickly. The arrangement of the fuel, so fuel can be arranged in different ways that will affect the fire behaviour. So loosely arranged fuel will ignite quicker and burn more intensely because drying is quicker, and also more oxygen is available among the fuel for the combustion process. As fuels are compacted, less oxygen will be available, less wind can penetrate the mass to drive off the moisture. So this is where we come to our experiment. The amount of moisture in fuel is the major element that will determine how much of the fuel will burn, so the availability of the fuel. According to how much moisture is in the fuel, all will burn, only part will burn, or if wet enough, none will burn. Of the fuels that do burn, when available fuels are moist in combustion, this is slow because much of the heat is expended in converting moisture to the fuel to steam. Fuel will not enter the combustion process and burn until the moisture is driven out of that particular particle of fuel and it has reached ignition temperature. As fuels become drier, the rate of combustion is increased because less heat is required to drive off the moisture that's left. Dead forest fuels pick up and give off moisture continuously according to dryness of the air, wind, temperature, and precipitation. As with temperature in the atmosphere, which continuously tries to equalize, causing winds and unstable atmosphere, the moisture in dead fuel is continuously trying to equalize with the amount of moisture in the adjacent air. Fine fuels, such as small twigs and grass, lose moisture rapidly and will have the greatest day-to-day variation. Heavy fuels, such as logs and large limbs, fluctuate slowly in the exchange of moisture.